Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we'll be finding the basis of 4 fundamental subspaces. Let's get started. Our example says, given matrix A, find the basis of the row space, the column space, the null space, and the left null space. Let's start with the row space. So row space is notated as R of A, or the row space of A. And here's the definition of the basis of a row space. It basically says that the non-zero rows of our row-reduced matrix A will form our basis. So this is our matrix A, and the first thing that we need to do is get this in row echelon form. We'll start by subtracting row 1 from row 3. Next, we're going to divide row 3 by 2. And then I'm actually going to subtract row 2 from row 3. Last thing I'm going to do is subtract row 2 from row 1. So we're looking for the non-zero rows of this matrix. Basically, we're looking for the rows with pivot positions. We clearly see that that is row 1 and row 2. So now taking a look back at our matrix before it was row reduced, the basis of the row space is row 1 and row 2. That is 1, 1, 2 and 0, 1, 1. That's the basis of our row space, and now we'll move on to finding the basis of our column space. Column space is notated as C of A, or the column space of A. And here's the definition of the basis of the column space. It basically says that the non-zero columns of row-reduced matrix A will form our basis. Now again, the first step is to row-reduce our matrix, and we've already done this work, so I'm just going to pop it in here. And again, here we see that our pivot positions are in column 1 and column 2. So therefore, taking a look back at our matrix before it was row reduced, the basis of our column space is column 1, 1, 0, 1, and column 2, 1, 1, 3. And that's the basis of the column space. Now, before we move on to null space and left null space, I'm going to show you all another way to find the basis of the row space and the column space. So I wanted to show you guys that sometimes row space is notated as the column space of A transpose, and sometimes column space is notated as the row space of A transpose. I kind of wanted to cover this because different professors notate things in different ways. So you may see row space notated as the column space of A transpose. You may see the column space notated as the row space of A transpose. And I just want to quickly show you guys how this works out. So the first thing that I'm going to do is transpose our matrix A. This is our matrix A transpose, and now I'm going to row reduce. Okay, so we've got A transpose in row echelon form, and now let's take a look at the basis of our row space. Our pivot positions are in row 1 and row 2. So taking a look at A transpose before it was row reduced, we see that the basis of the row space is row 1, 1, 0, 1, and row 2, 1, 1, 3. Now the answer that we got here for the basis of our column space is the same answer that we got here. So this checks out. Now for the column space of A transpose. Again, our pivot positions are in column 1 and column 2. So looking back at A transpose before it was row reduced, column 1 is 1, 1, 2. And column 2 is 0, 1, 1. This is the basis of the column space of A transpose, or in other words, this is the basis of our row space. Now I'll scroll back up so we can see that the first time that we found the basis of our row space, this is the answer that we got. Okay, that's enough on the row space and the column space. Let's move on to the null space. Null space is notated as n of A, or the null space of A. And here is the definition of the basis of a null space. It basically says that when we solve A times an x vector set equal to a 0 vector, this results in a spanning solution set. And that spanning solution set represents the basis. So we'll be finding the basis of the null space of matrix A. And the first thing that we need to do here is row reduce. We've already done this, so I'll skip ahead. So this is matrix A row reduce, and we're going to multiply this times an x vector. And then set it equal to a 0 vector. Now let's start solving this. We get x sub 1 plus x sub 3 equals 0. That comes from our first row. And our second row gives us x sub 2 plus x sub 3 equals 0. This in turn gives us x sub 1 equals negative x sub 3. And x sub 2 equals negative x sub 3. And row 3 is all zeros, so x sub 3 is free, or in other words, x sub 3 equals x sub 3. And so we see that the null space of A is spanned by negative 1, negative 1, 1. And therefore, the basis of the null space of A is negative 1, negative 1, 1. That's how you find the basis of the null space, and we'll move on to our last fundamental subspace, and that is the left null space. The left null space is notated as the null space of A transpose. And here's the definition. It basically says that when we solve A transpose times an x vector set equal to a 0 vector, this results in a spanning solution set, and that solution set will be our basis. So we're finding the null space of A transpose, and the first thing that we need to do is row reduce. Now, we row reduced A transpose earlier in this tutorial, so I'm just going to skip ahead. Alright, so we've row reduced A transpose, and we'll multiply this times an x vector. And set this equal to a 0 vector. And as we start to solve this, we see that we have x1, or x sub 1, plus x sub 3 equals 0. That's our first row. And our second row gives us x sub 1 plus 2x sub 3. Oh, I'm sorry, this is actually x sub 2 plus 2 times x sub 3 equals 0. And our entire last row is 0, so x sub 3 is free. So this gives us x sub 1 equals negative x sub 3. And then x sub 2 equals negative 2x sub 3. And then x sub 3 equals x sub 3. So now we see that the null space of A transpose is spanned by negative 1, negative 2, 1. And therefore, the basis of our left null space is negative 1, negative 2, 1. And there you have it. We have found basis for our 4 fundamental subspaces. If this video was helpful for you, give it a thumbs up, like the video, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.